Now you see the difference. This is the data that you directly generated through SCP plugin, and you can see the value range from 20.56 to 34.11. And what you can see in this method, you did the atmospheric correction and you follow the rest of the manual equations, and this method gives you the from 21.39 to 35 point something. So there is actually 1 degree Celsius difference between these two methods. Between these methods, that one is has been corrected using SCP plugin, atmospherically corrected and following manual procedure, and this one directly through SCP plugin. Let us compare this with the one that we generate directly through SCP. Okay, this is through the correction and following this correction plus manual equations, right? And let us do one more thing. Let us use through this SCP plugin. Okay, you directly, what you can do is just go to SCP, just go to, again you go to pre-processing, you go to Landsat, and what you are going to do is now you just go this. Let me tell you one thing. Now I'm going to show you another method. I'm just trying to compare. I know that I have already the results to compare, but also I want to show you live, so that I am trying to do this. So what other tutorial also do is that they just apply this correction and just tick on this brightness temperature in Celsius. Now what this does is that this band 10 automatically becomes the land surface temperature. If you tick this one, and it automatically becomes land surface temperature, but there will be minor deviation in the values. That is what actually I want to show here. You just go to run, and let me, so yeah, output SCP detect. You make one folder, select that folder, and just the rest of the thing, everything will be on processing. So you are going to get one brightness temperature that will be in Celsius. We are going to clip that with this shape file of Rupendahi 44 knot, and let's see what difference will be generated, and so that you can make your own wise decision which method to follow. Now we can see that output has been generated. What you can do is that okay, now I won't be showing anything else. I'm just going to go on this band 10, and just I will be renaming this to LST-SCP direct. So this is the SCP that you have obtained directly, this one, right? Now I will be clipping this SCP with this Rupendahi data and see the difference between these two methods. Okay, now you see the difference. This is the data that you directly generated through SCP plugin, and you can see the value range from 20.56 to 34.11. And what you can see in this method, you did the atmospheric correction and you follow the rest of the manual equations, and this method gives you the from 21.39 to 35 point something. So there is actually 1 degree Celsius difference between these two methods. Between these methods, that one is has been corrected using SCP plugin, atmospherically corrected and following manual procedure, and this one directly through SCP plugin. One more thing that I would like to say is that this method has not been used in I have not seen that the research papers that they have gone through this method. all the research paper have gone either through this method or through following all the equations directly, right? So as compared to this one method, obtaining SCP directly from those bands, I suggest you to go through this method because this has been atmospherically corrected as well. So what if you calculate land surface temperature through manual equation without any kind of correction, calculating directly this top of atmosphere, right, this one, and directly obtaining the brightness temperature going through NDVI and this one and this one. What happens? I just have calculated one result here, and the result that I obtained was that by doing without any atmospheric correction, just applying pure manual equations, I got the range from 21.50 to 35.12. 21.50 to 35.12, and that is almost like in these two cases almost similar. This one manual equation without atmospheric correction, and this one with atmospheric correction is almost similar, but doing the atmospheric correction is always a wise method. But I personally don't suggest this method, and this method has been backed up by research papers, and these all steps, all equation has been shown here, and this correction that I have shown you in this tutorial, this also have been backed up by the research paper, and I can provide you the references or the citation that these guys have used to calculate, to do their thesis or their kind of analysis. So finally, my suggestion is that you go through this atmospheric correction through SCP and follow the rest of the manual equations so that you can get this data, and make sure that you have the data, you have used level 1 product, and data is almost cloud free or very less cloudy, as everything will be hindered. So this was the main thing that I want to show here, and my reason behind making this tutorial was about confusion, because there were a lot of tutorial. Some guys were obtaining SCP directly, some guys were following these all manual equation methods, and research paper, I studied a lot of research paper, and those research paper also have followed different method. So after doing a lot of analysis, I came to conclusion that using this, doing atmospheric correction and then following the other manual equation method is what is best, what it suits for calculating LST. It may depend upon your study area and your analysis or project as well, but personally I feel that this method is the best. I provide you the PDF of this, all the resources that I have prepared, also the references that I have taken to prepare this tutorial. So this much for today. Thank you viewers. We are going to meet soon in other upcoming days, so keep supporting us.